Now, what I was saying that we are going to discuss about the data structure concept, which is called as stack. Stack is rather than a particular proper data structure, it is just a concept how you process the data. So far, we have seen about the linked list and the array. Both of them are the proper data structure which manage the data. How you are going to insert the data, how you are going to store the data, that is more related to the data structure, proper data structures. But how you process the data, that is more often concepts like stack. Stacks follows last and first row. Whatever the element you have put it in the last will be the first one to get implemented. Okay, will be the first one to get processed. For example, if we look into the real life analogy, then you have a stack of plates in any function, wedding or somewhere. Whenever you put a stack of plates, so whatever the plate which is put it later on is the first one to get out. Okay. Then next is, for example, browser. Whenever you browse a website, particular website, then what happens is you go keep on visiting it, but when you do a back, it will first come back to the last page which you have visited, then second last page, like that. Similarly, we have in practical implementation, we have seen the stack implementation when we have used the internal stack. So operating system is also used this stack. Okay, to maintain the stack frame for the functions. So these are the practical implementation of the and the real life implementation of the stacks. Stack. Now stack can be implemented with the help of linked list or the array. Okay, anyone can be used to implement the stack. The stack is more of a concept. Okay. It supports two major functions. One is called as push and another one is called pop. Push is a function which is used to insert the element inside the stack, and pop is the function to take the element out of the stack. Okay. Now there are some other things, like there are some other terminologies or there are some other utility functions. Utility functions are the functions which supports the implementation of stack. Okay. So what utility functions we have? No, utility functions we have like size. What is the size of the stack? Current size of the stack is empty. Whether the stack is empty or there are some element in it. Second is full. Whether the stack is full or not. Then resize. See, these utility functions are written by keeping in mind that it is implemented with the help of array. Okay, that's why whether it is empty, is full will work, resize will work. Okay, then top. Top is a variable which is used in a stack to represent that at what index the last element in this stack is. Okay, so these are the some utility functions in the stack. So as I told, stack can be implemented as array or a linked list. So keeping that in mind, if I have to write a class, okay, for this stack, I can have a array stack or a list stack. I can have a top, capacity, and the array to hold the elements in the stack. Similarly, if I'm going to use the linked list, okay, then I have a data. I have the next element. I have a list to maintain the linked list, and I have the size. What are the current size of the list? Okay. So these are the two classes that you can have. I have a very basic implementation of stack. I'm just putting it for the purpose of query. Okay, that you guys can go through later on. Okay, this is just a implementation of stack using the Java. That's it. I think everybody is pretty much comfortable with this stack. If you are using Java as a language or any other as a language, stack is pretty much available as a collection, part of a collection class. Okay, are we good? Guys, are we good?
Yes, Nisha.
Okay. Now let's move to the problem. Directly we can move to the problem. There are a few good problems which I want to discuss with you. Hmm. So one problem is palindrome. Palindrome is let's take a simple one. See, these problems can be solved with other approaches also, but just keeping the stack in mind that can be solved with the help of stack also. So suppose you have given a string, you have to check whether the string is a palindrome or not. Okay, first think about it, then you can see how it can be solved. For example, A, B, A. This is a palindrome string. So it should be yes. Similarly, another input could be A, so output should be yes. Can be like this. A, B, A, C. Output should be no, like this. Now, I definitely know we can check a string whether it's a palindrome or not by reversing the string and then compare both the string side by side. If both the strings are same, then the string is palindrome. Okay, that is fine. But can you think of an approach where you can apply the stack to solve this problem? Okay, take your time. Think how you can use a stack to solve this problem, and also, think for all the corner cases while you are thinking for the approach of this thing. Stack to solve the palindrome. Okay, is the problem statement clear to you guys? You can add this over. Oh, now think about it. Okay, let's see how we can solve this using stack. So the thing is, we find the middle of this string. Okay, we find the middle of this string. Find middle of string. Okay. Now the thing is, catch is for odd length string, you will be filling. So let's say middle is m. You will be filling from 0 to m minus 1 into the stack. Okay. And for even length, okay, there are two mids. So you will be filling from 0 to m. Okay. So, and then you start comparing with the rest of it. For example, this is our stack. Okay. So you have this string A, A, B, A, A. So the middle element is this. This is a odd length. So I will be inserting the first A, the second A. That's it. From the next iteration here itself, I will comparing A and A. They are same, I will remove it. They are same, I will remove it. Okay, like that. So this is one of the way to solve. Similarly, if you take a even length, for example, even length string is this A, B, B, A. So I know that this is the middle element. So I will be inserting the middle element also. In this, I am not inserting the middle element. So you have now B and B are same, you will remove it. A and A are same, you will remove it. Okay. So at the end, if your stack is empty, it means that it is palindrome. At any point of time, if the top of the element and the element in the string is not matching, then also it is not a palindrome. What is the complexity? The complexity of this approach is order of n. The space complexity of this is n by 2. Means you are using half the space only while storing into the stack. Sajan, Raju, cool. So now think about palindrome in linked list. Means given a linked list, you have to think whether it's a palindrome or not. See, the approach will remain same. Check whether it's palindrome or not. Normally, the input is like this. Okay, like this. So the output should be okay. So this is 1, 2, 3, 4, 3, 2, 1. Here also we need to take care of the odd length and even length. Depending. So the input is 1, the output should be yes. If the input is 1, 2, 2, 1, the output should be yes. Right. So think how you can implement this. You already know how to find the middle element in the linked list. Okay. Now think how you can do this. I think all of you understand how to solve it. Okay, so later on also you can do the implementation. It is going to be the same as a string only. You need to find the middle element of the linked list. And till the middle element, you have to uh, put the elements into the stack. And going forward within the linked list, just check the elements with the top of the stack. If they are same, pop it out. Okay, at any point of the time, if they are not same, then what you should do, you should just return no. Okay, so this implementation you can do later also. Smita, Raju, Sajan. Okay.
Yes, Nishan. Yeah.
Next problem is the quite important one. Okay. So suppose you have given an expression and you have to check whether it's a balanced expression or not. So given an expression, check whether it's a balanced or not. Okay. So we have three type of uh, so whenever we write a mathematical expressions, we use three type of brackets to decide the priority of them. So they are curly braces, they are simple braces, and they are square braces. Okay. So what you have to do? So whenever the equation is written, it is very important that in the sequence, the brackets are open. In the same sequence, they should be closed. Okay. So given that, you have to find whether the expressions is a balance or not. So it doesn't matter what the operator and operands are, it's all about the brackets. If the brackets are balanced, then the expression is balanced. Guys, are we done? Is it clear how we can solve this? What we can do, we can maintain a stack Guys, listen to me. How we can solve this? Okay. So what we can do, we can maintain a stack. Okay. We maintain a stack. We start traversing the string. So for all open brackets, we put it into the stack. We push into the stack. Okay. And for close brackets, compare with the top of the stack. Okay. For example, this is a stack. So I'm going through this. So I will be putting this, and I will be putting. I will come to this. They are the matching. Okay. If it is like square one, then they are not matching. Then it will return a no. They are matching, so I will pop it out. I will ignore this also. Then comes again this. Then this. So these are the matching. So at the end, if your stack is empty, then it means that these are the balanced one. Is it clear? Smita, Raju, is it clear?
Yes, Nisha.
Okay. Next is so what happens in mathematics is there are certain type of the expression: postfix, prefix, and infix expression. There are three types. So we have given a postfix expression. First, understand what a postfix expression is. In the postfix expression, you have the operators, you have operators, oh sorry, operands, and then operator, followed by operator. Okay. Normally, what mathematical expressions we see generally are infix, in which operator is present between the operands. So this is a postfix expression is given. We have to solve this. So how to solve this? 3, 2 plus 2, 4, 5 multiply minus and plus. So generally how we solve this is we check this to our operator, and whatever the operand we immediately found after the operands we apply to them, like 3 plus, so it will become 3 plus 2. Okay, so that is 5. Next is 2, 4, 5 multiply. So what happens? This multiply will be applied to 4 and 5. Okay, and remaining like this minus plus. So this will become 5 to 20 minus and plus. So 2 and 20. Okay. So you have an operand immediately after that, you have to apply them. So 2 minus 20. 2 minus 20 is minus 18. So 5 minus 18 plus. Again, these two are the operands and there is an operator, so that will be applied between them. So that will be equals to minus 13. Okay, so this minus 13 is the answer. Good. So think how you can solve this postfix expression. Okay. So how we can solve this problem? So to solve this problem, guys, listen to me. So, uh, yeah. So how we can solve this problem? We can take a stack and put, or we can push operands to this stack. Operands to this stack. Okay. So we have like this. What I say? Let's say we have a stack like this. So whenever the operator comes, whenever the operator comes, pop two elements and apply the operator. Operate. Okay. So and push back the result. Okay. So what happens is you have you inserted 3, you inserted 2. Okay. Then comes plus. So what you do? You pop 3 and 2 out. You do 3 plus 2. That will be 5. So you will be inserted 5 again. Next, which you got is 2, 4, and 5. Okay. The next operator is multiply. So you take 4 and 5 out. 4 into 5, you will get 20. So you will insert it 20 into this. Next is you got minus. So you pop 2 out. So 2 minus 20, that is 18. So this is becomes minus 18. Okay. Then you have plus. So you will take minus 18 and plus out. So 5 minus 18. That will be minus 13. So whatever the value remain, that will be the answer. Okay. So this is how we can use the stack to solve the reverse polish notation. Is it clear? Raju, Rajat, are we good? Raju, what about you? Yeah. So I will solve it anyway. So what we are going to do is we are going to iterate through the notation which is given to us or the postfix expression which is given to us. So there are two things. There are operators and operands. So 2, 3, 4, 5, these are the operands. Plus, minus, multiply, these are the operator. So whenever you find an operand, you will push into this stack. Whenever you find a operator, you will pop two elements out, apply the operator, and then push back the result. So, for example, here what we have, yeah. So here we have 3 and 2. So we start with here. So this is 3. This is an operand. I will put it right here. Then I will got 2. 2 is an operand. I will put it into this stack. Then I got plus. So what I will do, I will pop this 2 element out and do 3 plus 2, which is 5, and insert 5 back into the, or push back 5 into this stack. Next is 2 comes. So 2 will be here, 4 comes, 4 will be here, 5 comes, 5 will be here. Then I will take, so multiply comes. So I will take 5 and 4 out. So this will be like this. For 4 and 5, you need to apply to 4 and 5. That will be 20. So I will insert 20 back. Now comes minus. So I will take 20 and 2 out. So 2 minus 20. That will be minus 18. So I will put minus 18 into this stack. Then you have plus. So you will take 18 and 5 out. So 5 minus 18. So that will be minus 13. So we will be putting minus 13 over this stack. Okay. So the minus 13 is the only element left after the we solved it. So minus 13 is the answer. Are we good now? Asmita, Rajesh, Sajid? Cool. Now let's move to the next problem. This is a bit complex as compared to this. So suppose you, okay, there's one more problem that you can do it later. Suppose you have to design a data structure which can support push, pop, and get min. Okay, this we will discuss it. Or get minimum in order of one complexity. Design a data structure which have push, pop, and get minimum in order of one complexity. Think how we can solve this. This is purely you have to think on. Take examples. GetMin will return the minimum element in the data structure at any point of time in order of one. Also, inserting and taking out the element also should take order of 1. So if you are using about priority queue, GetMin is order of 1, but inserting and eliminating an element from the there is order of log n. So that cannot be used. Okay. I will give the LitCode link also. Okay, guys. How we can solve this problem? Anyone? Anyone?
So here for storing the minimum value, can we use additional field with the help of linked list? We can take up one more field to store the minimum value.
Okay. Okay. Let's do from the start. Okay. So, for example, let's suppose I have a stack. Okay, and I'm setting the elements like this. I have one. Let's say I have 3. So minimum element is if I'm using a variable to hold the minimum value. So 3. Then I will insert 4. The minimum remains 3. I will insert 1. The minimum becomes 1. I will insert 2. The minimum becomes 1. I will insert 0. The minimum will become 0. That is fine. Pushing and maintaining the minimum is fine. But the problem happens when you do pop. Okay. So when you take out 0, the minimum element is no more. The next minimum element should be 1. Okay. But a single variable can't hold the sequence of that. Okay. Because you already have a 0 stored. So you don't know what is the next minimum after the 0. So that is a problem. Okay. So what happens is to overcome that problem, we need to maintain the order of minimum values also. To do so, what we can do, we can take a one more stack, okay, and maintain the minimum in that. For example, I push 3. For 3, the minimum value is 3. For 4, the minimum value is 3. For 1, minimum value is 1. For 2, minimum value is 1. For 0, minimum value is 0. Okay, like that. So this is the original stack and this is the min stack. Okay. Now what happens here is this is the push operation. So at any point of time, you will get the minimum element at the top of the second stack. Okay. Now how the pop happens? So if you pop anything from here, you will pop also from the minimum stack. So if you remove 0, you will find out that the next minimum value is 1, which is already being maintained. For 2, I will be removing 1. For 1, I will be removing 1. So now you can see that for 4, the minimum value is this. Okay. Guys, give me. Okay, just go through this approach once more time. Okay, give me a minute. Asmita, Sajjan, is it clear? This part is clear. Why we need to take the extra stack to hold the minimum value?
Yes, Nishan.
Okay. Now this can be further space utilized. How? Right now what we are doing that for every element which we are pushing to this stack, we are maintaining the minimum element corresponding to that. Okay. We don't have to do that actually. How? We can, this is the optimizer. The approach is going to remain same by of taking an extra stack, but it's a better approach in the terms of the space optimization. For example, I push 3, minimum is 3 only. I push 4, so minimum remains 3, so I won't push anything for 4. 1 comes in, I will push 1. 2 comes in, I will not push anything because 1 remains minimum for 2. Then comes 0, I will push 0 for the stack on the min stack. Okay, minimum stack optimize. So I will not. So what happens is while you pop the element out, you have to check what is at the top of the min stack. So if the popping element and the min of the stack are same, then you will pop it out both of them. Okay, for example, like this. If you pop out 0, then you will check what is the top of the min stack. You will pop it out. You pop out 2, it is not same, so you won't make any change to the min stack. You just pop out 2. When you pop out 1, You will check the top of the minimum stack. It is 1. You will pop that out as well. For 4, when you pop out 4, you will see that the top of the stack is not same. So you will just pop out 4. If you pop out 3, and it will be like that. Cool. So this is the optimization. You can see that the stack on an average case will not be grow as same as like the original stack. Is it clear? Asmita, Raju, Raju is on. Sajan, is it clear? Okay, so you have to code this. Okay, not now. After the class, you have to code this. You have to take a class stack in which you can take two separate stack, and you have to follow the same thing. Cool. Okay, next problem is quite an important one. It is called as span. Actually, its name is stock span problem, but let's say it is span problem. So let me explain the problem first, and then you guys can see what exactly is. Okay, do one thing. This is the stock span problem. Coming to the part, yeah. So coming back to the problem. Let's start. This is a problem which we are trying to solve. Okay, and it came in multiple companies, Amazon, like that. So if I look at 1 year, Microsoft, Facebook, Google, everybody asks this. Go through the problem one time and try to understand what is it is saying. Okay. Just go through the problem once. Then we will start discussing. Okay? So is the problem statement clear? Let me simplify the problem statement for you. Okay. Just let me show you. Okay. Guys, am I audible? Can we discuss this?
Yes.
Okay. What it is said that you have to design an algorithm to collect the daily price codes for some stocks and return the span of the stock's price for the current day. So the span of a stock is defined as maximum number of consecutive days for which the stock price was less than or equals to the today's price. Okay. So if the stock over the so basically simply if I just say in a layman terms, it means that for a stock you have to check that for how many consecutive days it is being bigger than the other stocks. Okay. Let's see. Okay. So let's draw a graph here. Simple bar graph. Suppose this is 100. Okay. Let me write it down first. This is 100. This is 80. This is 60. This is 70. This is 60. This is 75. This is 85. Okay. So 80 will be represented by like this. Okay. 60 will be represented by this. 70 will be like this. 60 again like this. Then 75 is a bit more than 17, less than 70, 80 like this. 85 is like this. Cool. So this is a bar graph. Simply what happens is it is telling you that uh, how much for a stock, how much it is maximum for the consecutive stocks. For example, 75. 75 is greater than 60, 70, 60. So consecutively, it is greater than 3. Okay, so that's why, and it is including itself also. Okay, so including itself also, so that is coming as total as 4. Okay, so 75, you can see the answer is 4. If you look at 85, okay, for 85, for how many elements or for how many stocks it is consecutive stocks, it is greater than. So it is greater than from here till here. Means I am including the 85 also. There are 6 stocks which can come under this. So it is spanning till 6 stocks. For 100, there is nothing on the left side. Okay, because this is starting from day 0, 1, 2, 3. So we have to look on the previous day. So that's why 100 will having only one. Cool. Now is it clear what we have to do? So we have to find the maximum number of consecutive days for every stock. And it is already written that you have to go backward. Cool. Am I clear so far? Asmita, Raju, Sachin.
Yes.
Now, how we can solve this problem? One of the very naive approach of solving this problem is to, for every element, we have to find number of consecutive smaller elements on left side. Okay. So what I will be doing? I will be, for every I will be starting from here and check 0 to I minus 1. What is the small number of elements, consecutive number of small elements for that element. So for example, I is here. So from 0 to I minus 1, I will be checking the consecutive number of smaller one. Or I will be checking from 75 or move in this direction. Okay. I will be on 75 and moving in this direction and seeing what are the number of consecutive elements it can get, which are smaller than 75. So it can get 3. So that will. How far it can go? To an element which is greater than itself. So 80 is greater than itself, it can go till 80 only. Similarly, for 85, we can start moving into the left side till the element which is greater than 85. That is 100. Okay. So that we have to do. So what will be the complexity in that case for this particular example? Order of, for every element you have to go into the left hand side. So what is the complexity here, Smita? That is order of n square. Because for every element you have to go into the left side to check how many smaller consecutive elements it can span through or it can have. Am I clear? Or any doubts so far? Asmita, Raju, Sujan.
It's clear, Nishad.
Asmita, what about you?
Yes, clear, Rishant.
Okay. Now, complexity is fine because order of n square we are getting. So now what we can do is, if you look for any element, the bigger element on the immediate bigger element on the left hand side is creating the left boundary. Again, think about in terms of boundary. So the current element is the right boundary and the left boundary is the immediate greater element is the left boundary. So immediate greater element we have to found for every element. So whatever we have discussed in the array while solving the rainwater tap problem will not be useful here, because in rainwater tap problem what we try to do, we try to get the try to get the maximum in the left hand side. It doesn't matter whether it's an immediate or whatever, it always want the maximum maximum or this thing maximum element. Okay, so that will not work here because here we want the immediate one, because if you look for 75, 100 can be the maximum if I go by the logic of the rainwater trap problem, but here No, don't want 100. It is 80 actually. The immediate one when I move into the left hand side. So how we can maintain this boundary? Okay. The question comes is how we can maintain this boundary. So the second approach is we can use stack to maintain such boundaries. Okay. The current element, while using the stack only, the current element will become the right boundary and top of the stack becomes the left boundary. So stacks are also used to maintain the boundaries. Okay. Now let's see how we can maintain the boundary. Okay. So suppose you have taken a stack and listen to me very carefully. It is quite complex. So my stack is at -1. My top is at -1. So when a new element comes in, 100. I am writing the indexes also here. So it will be because we are going to do index calculation. Whenever you have to calculate the number of the elements within an array, always remember to do the index calculation. Index calculation is nothing but finding the number of elements between two indexes. Okay, number of the elements between two indexes that we call as the index calculation. Cool. So let's see. Let's develop the whole algorithm here. How we can use this stack to do so. Now, let's start. This one, this one, this one. Okay, so I have top of this stack as -1. Okay, so I have -1. Oh. Now the new element comes in. New element is 100, which is coming with index 0. So whenever I insert an element into this stack, I will do the calculation. Okay, whenever I add the element into the stack, I will do the calculation. So when we add or push element, we will do the calculation. Okay, we'll do the calculation. Now you have 100 and 0. So what happens is you insert. So the calculation will be, let's say the calculation will be current index is I and the top is 1. So toy minus top of the stack minus, let's keep that way and see whether we will get the correct answer of that. So 0 here right now is 0 minus -1. So that will be 1. Okay. So I will be writing answer here itself. Let me remove this thing. So for 100, I am getting 1 as answer. Okay. So I place 100 over there. Now, next is 80. So you can see that 80, 100 is the left boundary. 80 is coming with 1. And if top is greater than current element, we will do the push. Okay, we don't have to pop it out. We will just do the push. Okay. Else we do the pop. Okay. So if top of the stack is greater than the current element, we will push it. So 80 we will push it with index 1, and before pushing we will do the index calculation. So index calculation will be I minus top. So current element is 1, top element is 0. So 1 minus 0 is 1. So we are getting 1. Okay. So 1. Top is 1. Next element is 60 with index 2. 60 is coming, which is smaller than 80. Completely fine. We can push 60. Calculation we can do 2 minus 1 is 1. For 60 also it is 1. Now the top of this stack is at index 2. Okay. Top of the stack is at index 2. Okay. Okay. This is next element is 70. Now 70 is coming with 3. We know that 60 is smaller than 70 and it cannot be the left boundary for 70, so we will pop 60. Now what is your top of the stack? 80. So 80 can be the left boundary. So left boundary need to be greater than the current element. So 80 is there. So when we do the index calculation, 3 minus 1, which is 2. So 70 can be pushed with index 3, top is 3, and the index calculation help me to get 2, I minus top. Okay. Am I clear? Now, next is 60. Again, coming with 4. 70 is greater than 60. It can be a left boundary for 60. So 4 minus 3 is 1. And we will insert 60 with 4. Next element is 75 with 5. Now, 60 is smaller than 75, cannot be a left boundary, 70 is also not be a left boundary, 80 can be a left boundary. Okay, so we will do the index calculation. 5 minus 1 is 4. Okay, 5 minus 1 is 4, so we will do 4. Now we will put 75 with 5. Next element is 85 with 6. Okay, so what we will do, 85 with 6. Yeah, so 75 is smaller than 85, it will be removed. 80 will be smaller than 85, it will be removed. 100 will remain like that only because 100 is greater. So 6 minus 0 is 6, so you will be getting correct answer. So it will be 85. Here is 6. Now you can see that we have calculated the span for every node. Okay, so that's how we can use the current. We can use this stack to maintain the left boundary as the top of this stack. Okay, and the current element as the right boundary, and then we can calculate by using I minus top. Am I clear so far? What I want you guys to do is try it by yourself one time. Try to do it by yourself. Okay, Asmita and Sajan, you also just try it by yourself and see whether you are getting the answer or not.
Yes,
Cool.
Nishant.
Can you guys try to write a code for this? The link is above only. Okay, guys. So I have a code with me. Just go through it once, and it's a simple code only. Okay, and see whether you were on the same page while implementing the things or something else you had in mind. So there is one more problem which I want to discuss, but that I will cover with the queue when we will discussing the queue. Okay. This week I will try to have one extra class. Okay, if possible, that will be like in the evening, only from 9 o'clock. Okay, that I will try to. Cool. So that's it, guys. Okay, just go through the videos again and let me know. I will ask the I will ask admins to put the assignment for the stack as well. Okay.